Yeah, that depends on you. And when you unpack this whole thing, you find that this person is the IT network person who came out of his office and was supporting people a lot. Whereas one of these dots down here, more useful than his frequency of being seen was the IT person who was in the back, behind the scenes. Quite interesting that. Their job was about supporting people on their IT and they were therefore found useful, more than you would otherwise expect. One of the other dots of the outlier down here is one of the founding partners who just hadn't been around for 6 months prior to the particular set of observations because he'd been on sabbatical somewhere else. Not being seen, but still known and found useful. Yeah? And you could begin to unpack and explain a lot of this sort of apparent mess on the basis of these things. Now, let's just assume that being useful to your colleagues is an important thing in any knowledge-based activity. It's the reason why you get people together in an office or in a research laboratory in the first place, rather than everybody working at home. And since 80% of an organisation's running costs are on people expenses, it makes a lot of sense to try and make sure that the presence of the people maximally helps the other people to be productive. Yeah. We tried to find out what was going on here. So being found useful relative to frequency of being seen, well, the frequency of being seen thing, we could see potentially the way you design the building has an effect on that. So we did a whole lot of spatial analysis, we did a whole lot of observations of people, movement, behaviour, where they stood, where they sat, and so forth. And we did that on the basis of video recording and coding of that video recording. So this is a very simple coding which says, person sitting at this desk came up, moved over to the desk next door, turned back over here, interacts with somebody else who's walked up, sorry, my little pointer goes, and then another person, and then those two people wander off, this person turns back around and carries on working, and so forth. You can see the sort of coding through the thing. Turns out that interactions take place in a number of quite interesting ways. You're sitting there working in an open plan space in a concentrated fashion, and if you're sitting there with your head down working, basically you're not available to be interrupted. If somebody needs to talk to you, they'll come up and tap you on the shoulder and you'll respond. But by and large, you just sit there concentrating. As soon as you lean back and sort of start thinking about the latest word that you're going to type into the report, people catch you as being available. This is a real problem for open plan space, because you're just getting the right word and somebody interrupts you because they think you're now available. Yeah? And that problem is one which seems pervasive in open plan space. So what do? You build partitions around you. Yes, and you put them up about this sort of height to give yourself some privacy. Then, of course, you get all the disbenefits of the noise that comes over and the interruption that comes over. But what you don't get is the ability to recruit somebody wandering down the corridor that you needed to talk to. Yeah, so there's some interesting interactions here between micro-spatial design, micro-behaviour, how those are read by people, as whether or not you're available for being recruited into a conversation or not, and so forth. Now, one of the things we found was that something like 80% of work-related conversations happened in this way, that people would be recruited as they passed, or they would do some recruiting. Yes, both directions. So we did a whole lot of these different sort of shapes of laboratory building, and we came up with a little scatter here where we can measure the mean degree to which a space is accessible, all points to all other points within it, using space syntax methods. I won't go into the detail. The mean redness, if you like, of the analysis of connectivities in the space pattern. And each dot now is a whole building or organisation or a chunk of building. And then the mean usefulness of staff to each other. That's just the average of that vertical scale on the previous thing for each of those buildings. And what you find is a correlation. It's not brilliant, there's things here which are a bit dispersed, but what you don't find are major areas here or major areas up there. And every time we do another one of these organisations, what we tend to try to do is to try to reproduce the same methodology. In fact, our methodology has got better over time, and you'll hear a whole chunk of this from Kirsten, actually. So we're not quite as good at testing or keeping our body of evidence as it should be, if you like. But still, what you're finding is something that says that the more integrated, on average, the building, the more accessible, interaccessible its parts, the more useful the people are on average to each other within it. I'm going to skip through this. This is a set of stuff from Kirsten in which she looked at actually a chunk of our university, and the usefulness is being taken out. So the more useful, instead of having usefulness just as a yes or no answer, it was useful on a 10-point scale. And so you're looking there at 7 to 9, 8 to 9, just 9 usefulness, and you can see that that's densifying into different clusters. But I'm going to skip that. So take UCL, and let's think about some new technologies. We don't just interact by how we interact in space, we also interact by who we telephone up. Take the phone log for UCL, pretty much mapped onto the same map, and you can see there's an enormous density of phone interaction on the main UCL campus, and much less on the outlying bits of campus that are around the periphery. Yeah, so the densities of interaction on the telephones seem to also have something to do with structures of interaction in space. Now, this is something that I wouldn't expect would be reproduced now. This comes from probably about 10 years ago, maybe slightly longer actually, when people still use telephones. I think I've got a telephone in my office. I don't know the last time it rang. You know, it's one of those things that people are not using landlines very much anymore. Everybody's using mobiles, or more importantly, they're using email and other kinds of network-mediated technologies. But still, in the days when people did use telephones, and landlines in particular, there's a particularly interesting thing that you know it sort of does a ring, ring, ring for an internal phone call, and a ring, 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 ring for an external phone call. Well, that's the way a lot of switchboards operate. From a telephone log, you can see how often do people respond to internal telephone calls, how often do they respond to external calls for the same people on the same lines. And because you know who the people are on their lines, on the landline, you can actually find some quite interesting things. So here I'm going from most junior to most senior. And this is the correlation between external and internal phone calls answered. Junior people, absolutely uniform. External, internal, they answer. As you go up the seniority, they answer external calls in privilege to internal calls. Yeah, fascinating. Suspicion is that what people are doing with a new mode of communication is they're privileging external over internal, but they're also distancing themselves. They're using that mode of communication to distance themselves from their immediate work environment, yes, or from their immediate organisational structure. So although the boss is always in for the outside people, they're not necessarily in for their subordinates. This is not UCL, by the way. This is an organisation we were studying. Let me take a different thing that we've been doing a bit more recently. Working now, everybody has mobile phones, and they use those. The interesting thing about a mobile phone, of course, is you carry it around with you, and so you can use it as a device to detect the presence of people in space. In this case, we're using Bluetooth, and we set up a set of Bluetooth computers with Bluetooth dongles, and this is in urban space, actually, largely, in the city of Bath. Those Bluetooth dongles sit there continuously logging the presence of MAC addresses, the MAC IDs of mobile phones. And you get some interesting things. So in a particular location, let's look at this little scatter here. The way to read this is the first time a particular MAC address is logged, it goes onto a little scatter, and then time goes across horizontally. If it is seen again repeatedly, it appears as a little trace every time it's seen. Every time a new one is spotted, it goes up.